Hi, I'm Steve Cassidy. Today I'm going to talk about JavaScript, but really not so much JavaScript the language, as in teaching you the language, but just about JavaScript and its place on the web. We're going to talk about this idea of the browser as a platform, which is really just looking at what the capabilities of the web browser are. Web browser is a thing that displays web pages, obviously, but browsers have changed significantly since they started in around 1994, with the earliest browsers that were really just programs to display HTML content. We now have cascading style sheets, we have graphics, color, and interactivity, and JavaScript sort of plays a significant role in that. So we're going to look at the idea of this browser platform, which is really a cross operating system platform for writing complex web applications. It's the thing that now allows us to have things like Gmail, which is a fairly complicated application that just runs wherever it is that you happen to access it via a web browser. So how does JavaScript fit into this? How does JavaScript enable this web as a platform? So what is JavaScript? First of all, it was first introduced by Netscape in their Navigator browser as a way of scripting the behavior of the browser. Microsoft copied it. This was during the browser wars era, when Microsoft and Netscape were trying to outdo each other. They called their version Javscript, but it was essentially compatible, but obviously had some annoying incompatibilities, things that were different. It was later standardized and is called ECMAScript. So properly it's not JavaScript, it's ECMAScript. And all of the current browsers implement versions of this language, and occasionally with their own extensions, but these days it's a much more standardized language than it ever was. It's able to operate on the contents of the browser, on the things that the browser is displaying. It's operating in the context of the web browser, and so the main thing that JavaScript is able to do is change the behavior of a web page, and it can respond to user interaction and also other parts of the environment, like just what kind of web browser it is and what kind of requests are being made. Now, one of the things that we have to consider when thinking about JavaScript is that we're essentially allowing program code to run on the client's computer. When we're downloading and displaying HTML and CSS, we're really just taking a document that's a static resource, and the CSS is really just instructions on how to display it, what colors and things like that. No HTML and CSS code is actually going to ever do anything bad, other than maybe offend somebody or just look bad. It's never going to corrupt anybody's files on a machine or anything like that. JavaScript, however, has the possibility, because it's program code, it's instructions in the JavaScript language to do stuff, and we know that any program that's executable could potentially do bad things. And so we've got a security issue, particularly here. This is code that's downloaded from the web and therefore should not be trusted. Security's got to be a major consideration, and indeed it is. It's built into the design of how JavaScript is executed. So the question is, how do we ensure that when we're downloading code from the web and running it, that bad things don't happen? And this assumes that this is a good idea, but from the early days of the development of the web, it's been a fairly important thing to be able to do. So there are two general approaches to dealing with the problem of protecting ourselves from things that we're downloading. The first is to not trust the code at all that you're downloading, so we restrict, by doing that we basically restrict the things that the client-side programs are allowed to do, so they wouldn't be able to open files or talk to other things on the network and so on. Or we trust it, we trust the code that comes down, and therefore we need to somehow validate and verify the code that comes down. So we do know it's from somebody that we trust, It's not just from some random person who's likely to be bad. So they're just two broad approaches. Of course, there are nuances within those two. JavaScript takes the first approach. So the JavaScript language, for example, can't read and write local files on your computer. It's running in the context of the web browser, and it only has access to things that the web browser allows it to have access to. So whereas in Python or Java you could open a file, read from it and write to it and that kind of thing, you can't do that in JavaScript. And there are a whole bunch of other things that you just can't do in the language. The JavaScript environment prevents you from doing that. There are some other client-side languages that give you a restricted form. So the JavaScript language really just doesn't have read and write in its vocabulary. There are other languages like Java, and SafeTCL is another one, probably not very much used at all these days, but for a time it was an important language on the web. These languages themselves do have read and write capabilities and could do bad things, but the version that we get on the web is a restricted version, and so you're not able to do quite so many things as you are in the normal environment. Java, the story's a bit more complicated than that, but you know you're able to download and run Java applications, and they're effectively running inside a little sandbox, and they're not quite as capable as Java programs would be if you were to run them on your desktop. An alternative, which is not so widespread these days, although still used in some instances, is something called ActiveX. It's a Microsoft technology and is part of the Internet Explorer landscape. This is a technology, an ActiveX control is what they call it, a little program that you download and execute. You can essentially do anything, but it's signed and it's encrypted to help us trust where it comes from. So if it says it comes from Microsoft, then it's likely to come from Microsoft. We can check that, we can validate that, and then we just say, well, okay, I trust anything that comes from there, and I'll allow it to execute. And so, for example, the Windows Update code that you might run if you run Windows and that updates your operating system, which is obviously a very dangerous thing to do, is an ActiveX control that is running inside Internet Explorer, and it's signed and trusted. You know, we know that it's from Microsoft, and so we trust it to do the right things. So those are two sort of broad approaches to how dealing with security. Don't let it do anything, or let it do anything but try and work out whether or not we trust it. And obviously there are gradations within those. There are hybrids of those two systems and two ideas. So I've given the example of writing to a local disk as one thing that's obviously bad. Obviously you don't want to be able to fill up somebody's disk or read things from the disk and send it off somewhere else. But you know, there are other things like being able to listen to keystrokes and capturing them, sending data to remote sites. So you might be able to read something from a local disk, or even just read something from the browser context and send it to another site so that somebody else can capture that. And denial of service attacks is where you basically stop somebody using their computer. And so all of these things, you need to think about the implications of running code that you've gotten from the network. And JavaScript is an example of a system that's been designed so that it restricts the capabilities that you have. Very briefly, something about how JavaScript gets used in web pages, and we'll look at this a bit more when we actually look at the language itself. We have a tag called script, which is embedded in the web page, not necessarily often in the headers, but actually can appear anywhere in a web page. And the script tag contains either a reference to a file, or it contains the actual JavaScript. So it's sort of like the way that we include CSS. CSS must be in the head. JavaScript doesn't have to be in the head, it can be anywhere. And so you're just placing a little bit of JavaScript there, code there in the body of the page. So it's sort of tangled in with the HTML. The HTML tags are included to reference or include the JavaScript code that gets executed by your browser. We'll look at the details of that later on. So what does JavaScript do then? We've sort of seen it as a programming language that is downloaded and executed over the web inside our web browser. So we've got these different web technologies that we've looked at already. HTML, design, the structure of HTML pages, CSS style sheets that are looking at the style and the layout of the page, and JavaScript. Well, JavaScript is the thing that gives us the behavioral aspect of the web pages that we're looking at. Now, we already have behavior in a web page. When you go to a web page with no JavaScript in it, it will do certain things. In particular, for example, when you have a link, you can click on the link and it will take you to another website or a different place in the page. You have forms and you can click on the forms and certain things happen when you do that, and so on. So there are a limited number of behavioral parts of the web as it stands, but what JavaScript allows you to do is to add new behaviors, to make things change, to make things behave differently, and depending on user input or the context of the page or the context of the web browser. We can add much more complex user interactions. We can make the user experience of the page and of the web application much richer. And so in providing this for us, it moves the web from being this thing that just allows us to display content and exchanging documents, which was the original design of the web. If you remember back, Tim Berners-Lee designed this system for allowing scientists to exchange papers so that they could read each other's papers and interact in that way. Well, now we've got a very, very different kind of a web, one which is hugely interactive, which allows us to develop quite rich and complex applications that rival desktop applications. And JavaScript is really the major ingredient that enables us to do that. So if we look at a few different ways then that JavaScript is used, there are lots of different ways of sort of thinking about it and describing it. One interesting idea and approach is this thing called progressive enhancement, and it's sort of a development. It's like in a way slightly different to my point earlier about JavaScript being about behavior, because the idea of progressive enhancement is not so much behavior, although that might come into it, but it is being able to actively consider the environment that we're actually running in. Progressive enhancement is basically a way of writing web pages so that we start off with essentially a fairly plain page. It's got good, well-structured HTML, so we've written good HTML. And then we enhance it progressively. Now the first layer of enhancement is the cascading style sheets, and we know how to do that. So without the cascading style sheets, the web page would still be readable because it's good, well-structured HTML. It's got headings and paragraphs and tables and things like that in it. CSS makes it look prettier, makes the layout easier to read perhaps. But JavaScript comes in because we don't know when we're writing the HTML and CSS what the context of the viewing of this page is going to be. It could be a mobile device, it could be a desktop with a very large screen, it could be an old web browser, a new web browser, and so on. JavaScript enables us to have a look at the environment and then adapt the page to that environment. So this is sort of being active in a slightly different sense. We're not reacting to user input so much as reacting to the context that we're being displayed in. So we deliver a bit of code to the web browser that basically has a look at the web browser and says, oh, okay, I can see this web browser is a very modern one, and I'm going to be able to use new HTML5 features to draw flashy buttons and sort of a very swanky page layout. Or it might say, oh, well, it looks like we're running a very old web browser, and I better not add any of these other capabilities so that the page remains usable. Or I'm running on a mobile device and I'll adapt the page for page layout for display on a mobile device. So this is an interesting approach to the way that people are developing web pages these days, and it's actually it's becoming very, very common. There's this toolkit called jQuery, is quite often used in this way. I'll show you some examples on the next slide. It's an interesting contrast with this thing called graceful degradation, which is another way of thinking about the design of web pages. Graceful degradation says, well, design for the latest and greatest web browsers. So you design for, Internet Explorer version 10 or Chrome, the latest and greatest version of Chrome. But make sure that when you do that, that if you were to view it in an old browser or on a mobile browser, it would still look okay. And if you think about it, it's sort of slightly the other way around to the progressive enhancement approach, because you're sort of trying to take advantage of all the new features, but trying to make sure that if they're not there, everything's still okay. Progressive enhancement says just design a basic page and then have a look to see what is there and add the new capabilities if you can. They both have their strengths in some ways, and people would argue one way or the other which one is the best way to go. But I find progressive enhancement an interesting approach, and it is really interesting in the context of talking about the role of JavaScript in the web platform. Let's look at some examples. And these are all taken from the jQuery toolkit. And these are just samples from the jQuery manual, if you like. So this is jQuery UI, which is a jQuery user interface manual. And what we have here is a number of sections, and you can see that you can actually collapse and expand these sections based on by clicking on the little headers. Now that looks very swish, and if we look at the way that it's actually done, the markup for the sections is very ordinary. It's just sections and a div and so on. So there's nothing in here that would suggest that this is doing anything very clever. The cleverness comes, in fact, in this single line of jQuery here that says that find the thing that's called accordion, which is this thing here, and run this accordion function over it. It basically says make it into an accordion. So this is how jQuery works. It's actually really very easy to work. So that adds that capability. If we were to turn off JavaScript, then this would appear as just a plain HTML segment with headers in it. So that's one example. Another one is a date picker, and I'll just open that one, the third one for now. A date picker where we have a very simple entry in a form to select a date, which normally you'd have to type a date into, and then we click on that, and what jQuery has done, and again we'll look at the source. What jQuery has done is to add a date picker, a little pop-up thing that works there, and so that's sort of adding that capability. And jQuery, the library, if you're thinking where's the code that checks what the browser can do, jQuery, the library, does all that checking for you, so it will do something appropriate based on your device. And so if your device can't do the magic that enables this little pop-up to appear, then you won't get anything. You'll just have to type in the text. If you are on a mobile device that has its own date pop-up thing, then you'll get that. And so it sort of adapts to the environment that it's in. And the third example is from jQuery Mobile, and jQuery Mobile is a version of jQuery, or an extension for jQuery, that adapts websites for mobile use. And you'll see that some of these things look sort of mobile-like. I'm on a desktop browser at the moment, and so this set of pages is adapted to a desktop configuration. But if you were to visit this on a mobile device, then you see a mobile adapted version. In fact, it's looking fairly tablet-like at the moment, but I think it adapts itself quite nicely to mobile use. So this one is worthwhile having a look at. Follow that link on your phone and have a look at what the website looks like and how different it is in your mobile device. So they're just some examples of this idea of progressive enhancement, of using JavaScript to visually, and as you can see, the behavior of the things is different. You've got expanding and contracting bits of the page and so on. So JavaScript is used to enhance the page like that. Now, just on to a few other things that are quite often done with JavaScript. We've got application code or code that can run on the client side. One of the things that we can do with that is make one of the things we might want to be able to do that is make the page more responsive. And so form validation is one example of making your application, your web page, more responsive. It's always a good idea to validate the input in your form. So when you say enter an email address, it should be a real email address or valid, at least look like one. When you say enter a date, then you should obviously enter a valid date, and so on. Usually what we do is to send the data off to the web server. The server would make some checks on the data that has been sent in, and then return an error if the data is not correctly formatted. Since we've got code that can run on the client, we can actually validate the form data on the client before it gets sent. So we can write JavaScript to check that this looks like an email address. Probably can't check that it is a real one. We can check that the value looks like a real date or is in fact a valid date, not the 73rd of December, for example, and so on. And we can check this all before the submission happens, so we're stopping there being any more traffic on the network and providing a faster response to the client. We've got to be aware though that this doesn't mean that you don't need to check it when it gets to the client, when it gets to the server, because for example the client might not execute the JavaScript. They might turn it off, or they might be evil and they might be trying to fool your system into crashing and trying to crack into it or something like that. And so you still need to check things on the server side as well. But what we're doing here is providing the client with the user with a faster experience. Another use for JavaScript is the AJAX idiom. AJAX stands for Asynchronous JavaScript and XML, and we'll look at this in more detail later. The idea with AJAX is the code executing in your web browser is sending requests behind the scenes back to the server, getting the responses and updating the page while it's still being viewed. So you don't need a whole page being reloaded. You can refresh little bits of the page. Now AJAX is the basis of most modern web applications. Most modern websites use AJAX in some form or other, so it's important to look at that. But without AJAX, without JavaScript, we wouldn't be able to have AJAX, and without AJAX we wouldn't have the responsive distributed applications that we have at the moment. This thing XML HTTP request is the sort of basic building block of AJAX. We'll look at that when we look at it in more detail. Google Suggest, well, there used to be a thing called Google Suggest. Now it's really just Google. So the thing that sends tries to predict what it is that you're searching for is doing AJAX in the background. And so if I start typing here, if I type HE, what's happened is that the web browser has sent off a request saying, hey, they typed H and E to Google. Google sent back a little response saying, oh, well, they may be trying to type Hertz, for example. And then if I type L, then they send those three off. So each time, behind the scenes, without the page being refreshed, a request is going off back to the server, a response is coming back, and this little bit of code here is being generated. So AJAX is an important component, important feature and facet of the JavaScript environment. So we've got a fairly rich set of things that we can do with JavaScript. It's enhancing the behavior of our web pages and really making the web a platform in itself, or a thing that we can write fairly complicated user interactions with. As these interactions get more and more complicated, the performance of JavaScript as a system becomes incredibly important. If you've got JavaScript which is actually slow and clunky, then you're not going to get very good responsiveness from your user, from your applications. Now, in the early days, when JavaScript was really just for running little scripts that might, do rollovers of images or something like that, then it didn't really matter that it was a slow interpreted language. So in the early days, JavaScript was really a very slow, not a serious language for application development. These days, since we're doing more work, we have JavaScript engines that are now very, very good. So they approach native speeds in some cases for execution of code. And so you get things like V8, which is the Chrome JavaScript engine that's running in the Chrome browser, written by Google, SpiderMonkey, which is the Firefox one, and there are others. And these are sort of in themselves products, so you can actually get V8 as a standalone product if you wish. Similarly, SpiderMonkey to execute your JavaScript code. But they're built into these platforms, and Google in particular with V8 has spent a lot of time making this a very efficient code execution platform, because they need their applications like Gmail and Google Calendar and Google Maps and so on to execute quickly, to be fast and high performance applications. So a lot of work is going into these. They're now very good platforms for executing code, whereas before it was just a little interpreter that would run things not particularly efficiently inside your browser. So now we have a significant platform inside the browser to run quite complicated code on. So we're actually got a very capable environment to do work on. And another side effect of having high performance JavaScript engines like V8 and so on is that people are now starting to look at server-side JavaScript. Now, there were a few other incarnations of this earlier on, but they never really caught on. Most of the server-side programs done in languages like Java and Python and PHP and things like that. But now we're getting the development of server-side JavaScript tools and libraries like Node.js, and there's a link there you can follow to read a little bit more about that. Node.js is a toolkit for server-side development. One of the things it says, Node.js uses an event-driven, non-blocking I/O model that makes it lightweight and efficient, perfect for data-intensive real-time applications that run across distributed devices. And this is interesting because you're now getting JavaScript used for essentially distributed computing applications. May or may not be dealing with web browsers. So Node.js may be just talking to another Node.js server somewhere else and just doing distributed real-time applications in that context. But it might be talking, it's quite likely talking to a web browser that's got more JavaScript running in it. So you're seeing applications written in JavaScript, some of which runs on the server, some of which runs on the client, communicating over the web. Essentially distributed computing. Now, we've been doing distributed computing for a long time in the computing world, and sort of things go round and round, but this is an interesting development in the JavaScript web world, where we're getting platforms like Node.js running on top of these JavaScript engines. So that's worthwhile finding out a bit more about. So just to summarize then what I'm talking about here, JavaScript is this language that was developed for just adding behavior to HTML pages. It was added into web browsers to provide additional capabilities to make pages look a bit more flashy and make them interact a bit better with the users. Its security is an issue, and we constantly got to think about security when we're looking at JavaScript code and the execution environment. It's a big concern in the design of these systems, but the basic approach to security is we don't let the JavaScript do things that would be bad. But there are very, very complex issues around that, and we'll discuss a few of them when we talk about security as well. Now we've got these very capable, very fast JavaScript engines, and that opens a few new doors in terms of the kind of things that we're going to be able to do with them. So this Node.js stuff is an interesting development of running JavaScript on the server side, and the kind of things we're able to do on the client side now are quite impressive. So what we have with HTML and CSS and JavaScript is a standard and very powerful platform for application development. We can write applications now using these that will run essentially anywhere. They'll run on your desktop, whatever operating system you're using. They'll run on your phone, wherever you bought it, and they may well run on some other device that we've never heard of yet, because it's a very standard environment that we're working with. and JavaScript's not just in the browser, it's on the server, as I said. So that's just a broad introduction to JavaScript, where it fits into the landscape of web technologies, and how it's giving us this platform for web application development. Thanks.